All right, so I'm recording. I think we're doing all right. Here you got my little setup device here. You can see my face down in the corner as I'm teaching. I love this little thing. Only trade-off is I gotta use the old pen on the computer, which y'all don't like, but that's okay. All right, here we are. So we are in 2.3. All right, let's go ahead and start here. This is the 2.3. This is chapter 2.3, the third lesson. In our derivative unit. So we learned how to take the derivative and we learned how to graph the derivative and treat it as a function, all that good stuff. And remember that y'all are used to doing the definition of the derivative, right? The limit h approaches 0 of f of x plus h minus f of x over h. I mean, that is the definition of a derivative, and we found the derivative of a function multiple times using that. Okay, and I'll even let you try to do the warm-up with this. This is a very common question with derivatives, very conceptual. See if you can figure this out. We'll do it together tomorrow, but try doing it with this formula here. Okay, see if you can figure that out. But the good thing about today's lesson is that we are, well, we're no longer going to be doing that, right? We're going to learn the shortcut rules. Now, the shortcut rules came from doing this formula so many times that mathematicians smarter than me and you recognized the patterns, and they kind of came up with some rules based off of it. So let's look at these rules. Okay, and I think you're going to love these a lot. So differentiation rules. The first one here, we actually already talked about in our previous lesson, in the last lesson that we did. And that is what happens when you take the derivative of a constant. All right, so the notation I'm going to use is d over dx. That literally means the action of taking the derivative. So we are taking the derivative of a constant. We'll just call that arbitrary c. Okay, we already know that equals 0. Right? I mean, think about it. A constant looks like this. Well, it's a little bit more straight. That's awful. I gotta erase that. A constant looks like this, right? And what is the slope at any point on a constant? Well, it's 0. Okay, so I mean, I can give you a bunch of examples of this. I mean, the derivative of pi. The derivative of 3.14 is 0. The derivative of e is 0. The derivative of anything, any number, is 0. Okay, so nothing too bad there. And remember, the differentiation is nothing more than the slope of the tangent at an exact point. Okay, and these are the rules that we kind of came up with that helps us with that. So again, the rule was that the slope at any point on a constant is 0, so that's why the derivative of the constant is 0. All right, the power rule, one of the most common ones we use. That's the derivative of taking anything x to some power n. So it's literally taking the derivative of a polynomial, okay? Which we probably might have noticed this pattern before, and you'll see as we kind of relate back to the last examples. This is going to be equal to n times x to the n minus 1 power. Okay. Let me give you a very common example. What about when we took the derivative of x squared yesterday? Okay, what did that equal? Well, so basically what you're doing is you're bringing down the power of n. So we're going to bring down the power of 2. And then we're left with 1 minus the power for x. So 2 minus 1 power is just going to be 2x to the first, or 2x. And we already talked about doing the definition of the derivative, how x squared is equal to 2x. You can do this with anything. About the derivative of x cubed would be 3, bring the 3 down, and then 1 less power would be x squared. What about, here's another example I got. How about, here's one. For example, let's do the derivative of x. Well, the derivative of x is a power of 1. We can bring the 1 down, so we get 1x, and then 1 minus 1 power. So this is 1x to the 0, and x to the 0 is just 1. So 1 is our answer. The derivative of x is 1. I mean, that makes sense. This is a linear equation with a slope or an m value of 1 in front of it. So we've already even discussed that idea before, that the slope of a line is just the slope. Ooh, how about the derivative of 1 over x? Huh? So a lot of times you're going to get to the point where you want to write it in the form x to the n. So wouldn't you agree this is the same thing as x to the negative first power? And the derivative of that, if I did the power rule, I'm going to bring down the power, becomes negative 1x. And then negative 1 minus 1 is negative 2. Or if you want to rewrite that without a negative power, you could say, I just realized again that my video is covering this up. My face is covering this up. So I'll rewrite this in a second. But that's negative 1 over x squared. Okay, so I just realized my video is covering this up. That kind of sucks. So let me do this. Yikes, it is taking all that. I'll do this instead. Dadgummit. Lasso, come on. I hate this thing. It's only going to move a little bit of it. Are you kidding me? I'm going to do it one more time. Wait a minute. What's going on here? Can I move? Oh, no, I can't. I'm trying to show this to you. Stupid face covering everything up. Boom. Okay, well, I moved it over here. Dadgummit. Oh, well. All right, well, if you can't see it, we'll go over it more in class, and that's fine. But again, yeah, the derivative of 1 over x is negative 1 over x squared doing power rule, which is cool. Let's talk about the constant multiple rule. So this is saying if I have the derivative of a constant times some function. Well, all that's going to be equal to is I can take the constant out, and it's just a constant times the derivative of a function. Okay. I mean, here's a good example with that. The derivative of 4x squared. Well, that's the same thing as 4 times the derivative of x squared. And we know the power rule that's going to be 4 times 2x, which is just going to be 8x. So I do this more intuitively. Like, I just know that if there's a constant out front, I'm just going to multiply it by the derivative. And that's really it. I mean, I never really just separate it like that, but it's more intuitive. Okay. All right. So there's some main ones there. Let's go on to the sum and difference rules. So this is, again, I think this is pretty straightforward. It says, this is our little theorem here, that the derivative of some function f of x plus or minus the derivative of another function, and this kind of is a basic rule for a lot of things, is I can just separate that. I can take the derivative of x and then either plus or minus the derivative of g of x. That's it. All it means is if you have a bunch of things being added or subtracted together, you can just take the derivative individually of that. So for example, what if I had the derivative of the square root of x plus 4 over x squared? Okay. Well, you can take the derivative of this piece and the derivative of this piece. That's all that means. So in order to do that, you can take the derivative of each of these. You want to rewrite it in the terms of a polynomial. So you can do the power rule. So for instance, the square root of x is the same thing as x to the 1/2. And this 4 over x squared is the same thing as 4x to the negative second. And we know how to do the power rule for each of these. So I can bring down the power and then subtract 1. So that's 1/2 x to the 1/2 minus 1 is negative 1/2. And I can do the same thing over here. I can do times by negative 2. So that's going to be, I guess it's going to be minus now. Minus 8x. And then minus 1 power from negative 2 is negative 3. And that's our answer. But if we want to write it without the negative, we can say 1 over 2x to the 1/2 minus 8 over x to the 3rd power. Okay. So all we did was just take the derivative of each piece. Another example you can think of is, how about the derivative of x squared plus 3x plus 1, just taking the derivative of a quadratic trinomial. I can do the power rule for each of these. For x squared, bring down the power, it's 2x. For 3x, it's a power of 1, so you bring down and multiply, that's just going to be 3. And this goes x to the 0 power, which just goes away. And the derivative of 1 is just 0. So my final answer is 2x plus 3. Okay. And notice how with polynomials, the power just keeps going down by 1, right? I mean, x squared goes to x, 3x goes to no x. 4x cubed goes to 12x squared. See how it just goes down by a power of 1? And all I did was 3 times 4, and then bring it down by a power of 1. Okay, so sum and difference. Now I got 2 more I want to talk about. The product rule and the quotient rule. This is another observation, again, that was found by doing the definition of a derivative multiple times. It goes like this. It says if we have the derivative of a product of functions, so like f of x times g of x, okay, well, that can be separated. So it's not like the sum and difference where it's the derivative of f times the derivative of g. No, it separates a little bit different than that. I say it like this. The derivative of the first times, keep the second the same, plus keep the first the same, derivative of the second. That's it. So again, I say derivative of the first, keep the second the same, plus keep the first the same, derivative of the second. So it's not terrible. Let me give you a really easy example. Usually when we do product rule, it's more advanced than the example I'm about to give you, but this is just a good practice for doing the product rule. We have 2 things being multiplied together. So I'm going to do the derivative of the first. Okay, so the derivative of f, the derivative of this doing the power rule will be 18x squared, right? Bring down the power of 3 and subtract the power. So derivative of the first, keep the second the same, plus keep the first the same, so 6x cubed, and then the derivative of the second will be 28x cubed. Right? Now, you can leave it that way. That's your final answer. But if you want to simplify it further, you can. You can combine like terms here if you want. 18 times 7 is 126x to the 6th. And 6 times 28 is 168x to the 6th. And since they both have a base of x to the 6th, we can combine like terms, and that adds to 294x to the 6th. So usually, whenever you do product rule, it's going to be two functions that's not going to be like easy to combine together. So a lot of times when you do product rule, you can end it right here. But just to kind of show some comparisons here, this can also be done doing the power rule. Like if you can combine it at the very beginning, I recommend doing that. Isn't that the same thing as, let's see, 6 times 7 is 42x to the 7th? And if I take the derivative of that doing the power rule, 7 times 42 is 294, and then 1 less power is 6. So they're the same answer, but that's not always going to be the case. Like I'm not always going to be able to combine them together at the beginning, and then product rule is going to have to be a must. So We got to know that. Commit this to memory. And the last one, my personal favorite, is the quotient rule. So whenever we have two functions being divided by each other, so the derivative of like f of x minus g of x. All right. Now, I have a really fun way to remember this. I think it's fun. It's how I was taught. But this is what it looks like. It's not the derivative of f divided by the derivative of g. It's a little bit more complex than that. It's the bottom function times the derivative of the top function, okay, minus the top function times the derivative of the bottom function, all over the bottom function squared. And I didn't mean to write derivative, I'm sorry. The bottom function squared. Okay. Now, that looks like a lot. Okay, but this is the mnemonic way I help to maybe, this is what I say whenever I'm doing it. So I don't memorize that per se. I just repeat this right here. I say low d high, meaning the derivative of high, the top part. So low d high minus high d low, so the derivative of the bottom, all over low low. That's what I say. I say it a bunch. Low d high minus high d low all over low low. Low d high minus high d low all over low low. Low d high minus high d low all over low low. I say it so much that I never even write it this way anymore. I just remember that it's going to be low, so the low function, d high, the derivative of high, minus the high function times the derivative of the low function, d low, all over low low, so all over the lower function squared. Okay, let me insert another slide so we can do an example. Okay, let's do let's do this one. Oops. Ah. So I'm going to take the derivative of x to the 1/2 over 2x. Again, this is something you could probably simplify and do power rule with, but it's a good problem to help us know how the product or how the quotient rule works. So I'm going to say low 2x, d high. The derivative of x to the 1/2 is 1/2 x to the negative 1/2. That's just power rule. Low d high minus high, which is x to the 1/2, d low, the derivative of 2x. If I did power rule with that, this is a power of 1. Remember, the 1 comes down, it's going to be just 2, and then x goes away. 1 less power, x goes away. So low d high minus high d low all over low low, which is 2x squared. Now, a lot of times the quotients that we're going to be taking the derivative of, this is as far as we can go, which is what y'all love to see. But let's simplify this one down just a little bit, okay? Just for some good practice here. So first of all, this whole mess right here can be rewritten as 2x over 2x to the positive 1/2. All I did was bring this to the denominator and multiply it out. Minus 2x to the 1/2 all over 4x squared if I were to distribute the square. Okay, cool. Now we can simplify this a little bit if you want to. I mean, honestly, what we could do is, I mean, this can reduce down to 2, you know, that goes down to 1 over 1. And we can actually say we got x to the first power on top and x to the 1/2 power on bottom. Isn't that just going to simplify to x to the 1/2 on top? So I got x to the 1/2 on top minus 2x to the 1/2 all over 4x squared, which equals 1x to the 1/2 minus 2x to the 1/2. Isn't that just going to be negative x, negative 1x to the 1/2 over 4x squared? which if you want to reduce that even further, you can see that we got x to the 1/2 over x squared. Isn't that just going to be 1/2 minus 2 is 3/2 on the bottom? So negative 1 over 4x to the 3/2. Just doing some rules there. And again, a lot of times whenever you do quotient rule, it's not going to like be able to simplify all that way down. So a lot of times you just have to leave it like this. But again, this is just another example of something you could do with power rule. Like from the very beginning, I can simplify that down. X to the 1/2 over 2x, doesn't that reduce to 1 over 2x to the 1/2? Which I can rewrite as 1/2 x to the negative 1/2. I just brought the power to the top. And now I got it in a form when I can just do power rule. Okay. So if I do power rule, I'm going to bring down the power of 1/2. And 1/2 times negative 1/2 is negative 1/4 x. And if I do 1/2, negative 1/2 minus a power of 1, I get to negative 3/2. Which if I rewrite that with the power on bottom and not negative, it would be negative 1 over 4x to the 3/2, which as you can see is the same answer as doing the quotient rule. So if you can simplify it down from the beginning, great, do that. It's less steps, but it's still important to know all these because sometimes you can't do that. All right, and that's all the rules, guys. That's it. So I got some like 6 practice problems that we can do here. And honestly, I was just going to do these with y'all in class. Maybe I'll do the first one to kind of get you on the right track, and you can finish these as much as you want. But like for instance, right here, I got 4 terms being added and subtracted together. So I can take the derivative of each term. So 2x squared, the derivative of that is 4x, right? You bring the 2 down, you multiply it, 2 times 2 is 4, and then it goes from a power of 2 to a power of 1. All right, for x to the 1/2, or remember square root of x, that's the same thing as x to the 1/2, and I can take care of that doing the polynomial rule, right? I can bring the 1/2 down, so that's going to be plus 1/2 x, and then 1/2 minus 1 is negative 1/2. Okay. Now remember that 3x squared, so 3x squared can be, or 3 over x squared can be rewritten as 3x to the negative second. So if I do that doing power rule, that's going to be minus negative 2 times 3 is negative 6x, and then negative 2 minus 1 is negative 3. And then lastly, pi is just a number, and the derivative of a constant is 0. So what I'm left with is 4x plus 1 over 2x to the 1/2 plus 6 over x cubed. Yay! Ta-da! Okay. All right, see if you can try these other ones. Again, my suggestion is to rewrite the terms as polynomials if you can. Here you want to do quotient rule. Here you can do one of 2 things. You can either distribute or you can practice doing the product rule. I'm going to let you try to reason through number 5 here. I'm going to let you try to reason through 5. And then again, you could do quotient rule here or you could simplify. So I'll let you reason through these, and you can check my notes online if you want, but we're going to do those in class. Go over all these rules because you're going to be experts at these by the time we're done with you. And then your homework is just page 136, 2 through 42 even, and it's just a bunch of rules. That's it, just a bunch of shortcuts. So yeah, that does it for me. Shorter lesson. It was only 24 minutes, and that could have easily been 15 minutes if I didn't go into so much detail and give you so many examples. But anyway, you got this. Good luck, guys. Y'all are awesome. Go Bulls.